Hi, my name is Angela Merrill, and I'll be doing an emerging technology report on self-healing materials. Nothing lasts forever. Materials are subject to aging, defect, and wear. For material scientists, spontaneous failure is the most dangerous and most difficult thing to prevent. Although large defects can be easily spotted through routine maintenance, it's those small fractures and hairline cracks that are difficult to notice, especially while these materials are in use. The ability to self-heal is one of nature's most impressive features. Self-healing in everyday materials, however, appears to be something out of a science fiction movie. This may not be the case for much longer. Material scientists are developing metals, plastics, composites, paints, and coatings that can sense failure and repair itself without intervention. The current list of self-healing materials can be categorized into four main areas. Healing agents, it's the best known self-healing materials, have built-in microcapsules, or tiny embedded pockets. They're filled with adhesive and repair the damage. When a material cracks, the capsules break open, releasing repair material to seal the crack. It's similar to using epoxy. The main drawback with the encapsulation method is that capsules have to be very small or they can weaken the material. This limits the size of the crack they can fill. Also, once a capsule is broken and used, it cannot make any further repairs. The second type is a sort of internal vascular circulation material, and it's similar to the blood system. Instead of blood, however, adhesive are pumped through the material and flow to the area of repair. This method is slower than using microcapsules, however, it's ideal for slow-moving failures that creep, such as on bridges or skyscrapers. Also, if adhesives are pumped through the system, they can be used multiple times. The third type is shape memory materials. This is similar to items that are already in use, such as eyeglasses with flecks in them. Heat or an energy supply is required to get the material to snap back to its original form. In practice, this may be an embedded fiber optic network that will feed laser light or heat energy to the point of failure. This will cause the material to flip back to the preferred shape, effectively reversing the damage. And then the fourth type is reversible polymers. Energized by either light or heat, these fragments naturally try to rebond themselves to other nearby molecules. They have a built-in electrostatic attraction so that when damage occurs, electrostatic forces pull all the pieces together, allowing for self-repair. Reversible polymers also include other plastics that use heat to break down. Once the material cools, the original polymer reforms, reversing the damage. If you can imagine a bullet going through a material made of reversible polymer, the heat from the impact will produce enough energy, allowing the material to reseal its own hole. Another good example in this category would be having a coating on your car that you'll use the sunlight and heat from the car to repair itself every time a scratch or a nick occurs. So the potential benefits of self-healing material are that it cuts down on costly maintenance and inspection. If the materials are healing themselves, less human interaction is required. There's an extended lifetime of safety products, and they can prevent catastrophic failures. There's a reduced demand for raw construction materials, again, because products have an extended lifetime. It allows machines in remote or inaccessible locations to stay operative. Healing can occur without the presence of oxygen, which is huge, especially when you're using offshore equipment or underwater equipment. That's very difficult to get to. And then also materials could circulate water through that vascular system, and this would help reduce material temperatures. If you can think about the implications this could have on computer chips or electronics. Some areas of potential transformation: self-healing electronic devices, for example mobile phones. Think about every time you drop a phone and your screen wouldn't break. Remote equipment and machinery, again, human interaction or intervention and even oxygen is not required. Bridges and buildings, repairing seals and gaskets for piping. The automobile industry, if you had a shape memory bumper, these small fender benders, it would automatically flex back to its original shape. Military equipment, during combat, if there were coatings or other things on the glass, these could easily hold themselves together and you can continue battle. marine assets, ships, docks, oil and gas platforms to protect metal beneath water from corrosion, paints and coatings, and then also, again, computer chips and other electronics susceptible to overheating. Potential issues. These materials are sensitive to extreme conditions and environments. This could be problematic and limiting. If you think about extreme cold, extreme heat, they could fail even before, completing what they're supposed to do. Materials have a tendency to want to change and are unstable. Residual damage. Self-healing materials do not restore material to its pristine state. It's a functional fix, purely, not aesthetic. Think about a car. If this were the case, you would see these like bruises all over a car that are happening. The vascular system option could become blocked or failed. In the self-healing microcapsules, the macrocapsules are finite. As they get used up, the material loses its self-healing properties. There's a large initial investment, obviously. However, over time, it's less maintenance and less repair from a human intervention aspect. So it's probably a trade-off depending on, what it's used for. And then long-term, are there health or environmental implications? I think that's something that really hasn't been discussed, at least in the readings that I found. And then how will these materials be disposed of? Granted, they're not going to last forever, so eventually they'll have to be replaced. And then some discussion questions. How could self-healing materials be used in your company or industry? Does this have the potential to be a disruptive technology in your industry? How could these materials improve existing products? From a consumer goods standpoint, would you be willing to pay additional for self-healing materials on your phone, on any devices? And then what would they be worth to you?